Hi class, we're ready for Wolf Review Set 5, Slide 4. First, we're going to find the product of 54 and 12. Product means multiply, so we're going to take 54 times 12. We'll do it both ways. The box method and algorithm. First, we're going to take our ones times our ones, then our ones times our tens. Ones times our ones is 8. 2 times 5 is 10. Tic-tac-toe, bring your 0 below. Gets me to my tens. I take my tens times my ones, and my tens times my tens. These are my partial products, which are part of the product. I add them together, and I get 648. Here, for the box method, I'm going to take 54 and 12, which is 10 and 2. And going down, 50, 50. 4, 4, going across, 10, 10, 2, 2. We're going to multiply. I have 2 zeros, box them, cross them, bring them down. 5 times 1 is 5. 1 0, box it, cross it, bring it down. 4 times 1 is 4. 1 0, box it, cross it, bring it down. 5 times 2 is 10. And 4 times 2 is 8. Again, my partial products. Add them up, and I get the same product. As usual, I don't care how you solve it, just as long as you get it right. Here we're going to find the sum of these two numbers, and remember sum means to add. 8 times 9, 1 less than 8 is 7, so it's 17. Again, I made a 9. 1 less than 5 is 4, so it's 14. 1 plus 7 is 8. 3 plus 5 is 8. 4 plus 3 is 7. 78,847. Wendy's new puppy weighed 3 5/7 pounds. But after a month, it gained. Gained would be adding more weight. He gained 8 1/7 pounds. That's a lot. How much does he weigh now? So, we're going to add our fractions first. If our denominator is the same, we keep it the same. 5 plus 1 is 6. 8 plus 3 is 11. He now weighs 11 6/7. And it says, how much does he weigh? I'm doing a lot of S's. How much does he weigh? Well, we don't say weigh. We have to look for our... can't think of the word right now, but we have to look for our word that shows if it's like inches or feet. Here we have pounds, so that is what it is. Drawing a blank on the word I'm trying to find. Here we're going to solve when we multiply whole numbers times fractions. Remember, we can put under every whole number, we can put a 1. I'm going to remind you why. 1/1. I hate saying that. Plus 1/1, plus 1/1. Remember, 1/1, 1 whole, 1/1, 1 whole, 1/1, 1 whole. Denominators the same, we keep it the same. Add our numerators. 3 over 1 is 1, 2, 3 wholes. Okay, I take my numerator times my numerator, and my denominator times my denominator. This is improper because my numerator is greater than my denominator, so we have to divide to make it proper. 15 divided by 8, it goes in 1 time, and the remainder is 7. Going straight across, we put a 1, we put a 7, and our denominator stays the same. So 15/8 is 1 whole and 7/8. Again, under every whole number, we can put a 1 when we multiply. 8 times 3 is 24. 1 times 6 is 6. Again, it's improper. Here, I can just know, I know that 6 times 4 is 24, so this actually goes in 4 whole times. Doing the same thing, under every whole number we put a 1. Numerator times my numerator and my denominator times my denominator. I could do this in my head. I know 3 goes into 7 2 times. 3 is 6. 1 more would get me to 7. My denominator stays the same. If I wanted to do the work, same thing. Going straight across, whole number, remainder, denominator. My quotient is my whole number, my remainder is my numerator, and my denominator stays the same. Here, Luke stacked 7 pieces of wood on top of each other, okay? So 1, 2, 3, 4, 5, 6, 7. Each of these is 4/8 tall. How tall is the pile? Well, we have 7 groups of 4/8. So we can do 7 times 4/8. We could also add 4/8 7 times. I could do 4/8 plus 4/8, 4 plus 4/8. That would take a while. Under every whole number, we can put a 1. I take my numerator times my numerator, and my denominator times my denominator. 28 divided by 8, count by 8s, 8, 16, 24, goes in 3 times, with a remainder of 4. Going straight across, whole number, numerator, denominator stays the same. 3 and 4/8 feet.